Good morning, students. In the previous period, we have calculated the potential at a point inside the solid sphere, outside the solid sphere, and on the surface of the solid sphere. Today, we will calculate the gravitational field on the surface of the solid sphere, outside of the solid sphere, and inside of the solid sphere. First, from these three cases, first we will see the gravitational field at a point outside the solid sphere. Gravitational field gravitational field at a point at a point at a point outside the outside the outside the solid sphere. We will discuss this case in today's period. In the previous period, we have calculated gravitational potential at a point outside this sphere, and this it is given by the in that for that we have considered this is a solid sphere. Its center is O and particle is situated outside this solid sphere. Now we want to calculate the potential gravitational field or gravitational field intensity at this point. We know that the gravitational potential is given by this is the distance is given by V equals to minus capital Z em upon R. From this equation we have calculated the gravitational potential. But since the gravitational field due to a solid sphere at a point is equal to the potential gradient, gravitational field is equal to the potential gradient. Therefore, the gravitational field due to a solid sphere at a point at distance r from its center is given by E equals to minus dV by dr of V or minus dV by dr. With this formula, or this is the gravitational field intensity. As a gravitational potential is the gravitational sphere at a point is equal to the potential gradient. Therefore, it is given by E equals to, that is potential gravitational field intensity is minus dV by dr. In this equation, we will put E equals to minus d by dr of this minus z m upon r. In this equation, z and m are constant, and therefore we will take it outside the minus of minus z m upon d by dr of r. This minus minus sign will be positive. It is positive, and therefore we have to differentiate this r, and this can be written as, therefore E equals to Gm into its differentiation is 1 into r raised to r minus 1 or minus 1. This directly we can write minus Gm upon r, and this is the potential gravitational field due to the here it is minus 1. Okay, then with this formula, we have calculated the gravitational field at a point outside the solid sphere. This equation gives the potential gravitational field intensity outside the solid sphere. Now, for the second case is the gravitational field at a point inside the solid sphere. The second is the inside the solid sphere. Inside the solid sphere. For this, we will consider a solid sphere and the point is lie inside the solid sphere. And for this purpose, already we have calculated, we have discussed this case for calculating the gravitational potential. Here O is the center and suppose this point P is lying inside the solid sphere. For this case, we have calculated the gravitational potential and that is given by, yesterday we have calculated this gravitational potential when particle is lying inside the solid sphere. Now today we are calculating the gravitational field as a gravitational potential is equal to the potential gradient. Therefore, here we have that formula as minus mg into 3r square minus r square bracket close upon 2r2. This is the gravitational potential at a point inside the solid sphere. But the gravitational potential equals to the gravitational potential gradient. Therefore, we can write this as E equals to dV by dr. dV by dr. Therefore, here we can write the value of, or we can differentiate this above equation with respect to r. Therefore, it is mg into the bracket 3 r square minus r square upon 2 r cube upon 2 r cube. Now, for differentiating this equation, we write it as like this, as this mg upon 2 r cube is constant, we will take it outside the 2r cube and differentiate this bracket sign 3r square minus 3r square minus r square. This can be differentiated like this, mg upon 2r cube into the r is the constant, its differentiation is 0 and it is minus of 2 into r raised to 2 minus 1 and bracket close. This can be written as E equals to mg into the bracket minus 2r 1 upon 2r cube and therefore this can be written as E equals to minus